All right, so if you are getting this video, just want to keep you caught up for what we did on Monday, the 7th, because this is really, it's probably one of the biggest things we'll learn in chemistry as far as setting yourself up for success, and understanding when we get to bonding and chemical reactions and all this stuff. This is really kind of the fundamental thing that we need to understand about atoms. Okay, so our goal is we want to be able to fill in electrons into specific energy levels. And you're going to find later on the number of energy levels they have, and the number of valence electrons in those energy levels is really what is going to determine the properties of an atom. So when we say something is very reactive, like potassium or lithium, it has to do with these energy levels and how they're filled and what groups they're in. Okay, and then so to be able to represent that, we're going to do something called an electron dot diagram. Okay, and it's very simple, but again, it is one of those things where if you can get this and understand this, it makes everything so much easier. Okay, so what we're going to do, we're going to review, talk about what we know about atoms so far, look at groups versus periods on the periodic table, and kind of see how that connects to these other two things, so filling energy levels and valence electrons. Okay, so the first thing is we talked about just in our groups um, where have we gotten to with chemistry so far? So we started out looking at atoms, we built atoms, we saw the subatomic particles and what role they played, and then kind of where did they come from, right? How did we get these here? So where they came from, this was based on the project last week, right? So they came from our stars, right? And so starting with the Big Bang and pushing that matter out into the universe, and then that matter then forms stars, and then we can have nuclear fusion. That's how we got elements that were bigger than just hydrogen, right? And so eventually through the star cycle, once you get to a supernova, we get the super big heavy elements blasted into space, bing, bang, boom. We wind up with a planet now that has 92 naturally occurring elements, okay? Then what subatomic particles are there? Okay, we know we have the protons, neutrons, electrons. And we know if we look at an element card like this, wow, look at that. For lithium, we know that the atomic number is 3, right? And that's going to tell us our number of protons. Okay, so that's going to tell us protons, and that's going to also tell us the number of electrons, right? If it's neutral, we're going to have the same number of protons, electrons. We're going to look at that a lot today. And then the mass down here is going to be the protons and neutrons. So that's going to be, to be able to find our number of neutrons, we're going to be able to just take 7 minus 3, and that's going to tell us neutrons. Okay, so we just want to review some of those things that we learned last week. Okay, so now, for example, here when we look at this, it says, okay, how many electrons do they have? And again, with the periodic table, we're just going to assume that they're neutral unless we see something that tells us that there's a charge, right? So all these are neutral, so it's very easy, right? This one, we have 10 protons and 10 electrons, 47 protons and 47, wow, that's an ugly E, 47 electrons and 17. So it's very easy, right? We are given that information here. So now how do we fill these things in? So we should have this handout. So I just want you to glue this into your notes. And so we can break our periodic table down to groups and periods. Okay, so the groups we can see are grouped vertically. Okay, so all these red ones that are colored red are in the same group, and that's group number 1. Okay, same thing here. The orange ones are in group number 2, and then we have 3 through 12 down here, and then we have 13. Oh, that's supposed to be a 3. Oh, ugly 3. 13, 14, 15, 16, 17, and 18. So I want you to pause the video real quick and draw all those numbers above on your groups. And you'll notice when you look at periodic tables, you see this as well. Okay, so go ahead and pause that and draw those real quick. Okay, then what I want you to do now after you've done that is above each of these. So this here, this section here, This is known as our transition metals. They get a little bit weird, and they don't really follow the rules as strictly as our other elements. So a lot of the time, when we're looking at electron orbitals and things like that, we're going to kind of ignore those. And we focus on these colored elements here. And it helps us also to understand that that is group 13, but we can also put a 3 above it. This is group 14, but we can also put a 4, and then a 5, and a 6, and a 7, and an 8. We're going to talk about why. That becomes very, very important later on, okay? Now, periods, just the same thing, but the other direction, right? So these two, hydrogen and helium, they're in the same row, right? And that is period 1. Okay. Then all of these elements going across, all these orange, are in period 2. So take a second, label these. We should have 1 through 7. Okay. Now, right below that, I want you guys to add this to your notes. So underneath the periodic table that showed us the periods, that's the horizontal rows. There are 7 periods, and each element in the period has the same number of energy levels. Okay, this is going to be really important. We're going to talk about what we mean when we say energy levels. Okay, so we're going to add that there. Same thing with groups. Okay, so go ahead and pause the video and add this to your notes. Now, this is kind of the key here. Okay, so what we did, we want to write down these rules for creating an electron dot diagram. So when we look over here, this is an electron dot diagram. Okay, and all it simply does is allows us to see where our electrons are, what energy levels, energy level 1, energy level 2, how many electrons are in each energy level. Okay, and we can do this with a couple simple steps. Okay, so first thing we need to do is when we look at the element card for oxygen, we need to figure out, okay, how many electrons do we have total? Okay, so just like we did with the warm-up, we know my atomic number is 8. So that means I have 8 protons, which means I have a total of 8 electrons as well. Okay, so I know I have 8 protons and 8 electrons. Yep, there we go. Okay, so then it says draw a circle around, or draw the symbol and then draw a circle around it. Okay, so that's what this is. So this yellow dot represents the nucleus, and we know it's oxygen. Okay, then it says draw your first energy level, which is just a circle around the nucleus. Okay, there we go. Then it says begin filling in the electrons, right? We need to fill in 8, following the rules below. Okay, so the rules are first energy level can hold 2 electrons. Then we have to go up an energy level. Second level can hold 8. And then the third one can actually hold 18, but usually we stop at 8, and we'll talk about that later on. But so basically, I told the classes, it's kind of like if you were filling up water jugs and you had gallons, right? So you're filling up that water jug. Well, when that gallon gets full, you have to go to another water jug. And so that's kind of the same thing with these energy levels. Once this energy level's full, we have to add another one. Okay, so if we follow this progression, we start from the inside, and we'd start with this one, right? So we have 1, 2. Now that first energy level is full, right? So now I have to add this second energy level, and I keep going. So I'm at 2, 3, 4, 5, 6, 7, and 8. Okay, now you'll notice you might say, hey, Mr. Hart, then you're weird and you did that in a really weird way. That's actually how I want you guys to do it, because when we get to bonding, these unpaired electron or paired electrons versus unpaired electrons become very important, right? So I want you to start at the top and then you go around like a clock. So it'd be like right here, then to the right, bottom, left, back to the top, right, bottom, left, and so on. Okay, and that pattern, and then it does another thing. It really allows you to easily count how many electrons you have. So I see I have 2, 4, 5, 6 in the shell. I know that I could fit another 2 electrons if I needed to. Okay, so that's really the biggest piece. Okay, is filling in those electron orbitals. This is very, very important when it gets to bonding. Okay, so with this, what you're going to do is you're going to go through and you're just going to practice, and it's going to get a little bit repetitive, but once you get it, you'll see it's very easy. So you can see I drew the nucleus, okay, and then the element symbol, and then I notice, okay, I got 1 proton, which means I need 1 electron, okay, and I've already done helium, right? We had 2 protons, 2 electrons, so here's my 1, 2 electrons, okay? Then you're going to go through and use the periodic table, Okay, so I got lithium. There we go. And we can fill these in. So 1, 2, 3. And notice I put the first 2 in the first energy level, then it's full, so I had to go out here to the outer one. So go ahead and do that, and then we're going to look at some patterns, okay? So go ahead and pause the video. So now it asks, what patterns did we notice, okay? So if you look at your periodic table, what we should see is this, right? When we did hydrogen, we had 1 electron around it in its outermost shell. When we did lithium, in its outermost shell, we had 1 electron, okay? And we had 2 in here, okay? Same thing for sodium. We're not going to draw all the electrons in there, but we had 1 valence electron. There's that term, valence electron, okay? And then group 2, they had 2 electrons in that outermost shell, okay? And that pattern continues as we get to these. We're going to have 3. So just make sure we notice that, right? So the group number tells us the number of valence electrons. And when we go back to our notes, that's what it tells us right here. So the valence electron is very important, and that's identified by the groups, okay? And the other pattern that we should notice is hydrogen just has this 1 energy level, right? Same thing with helium. Here it is. Here's our 1 energy level, okay? And then lithium has 1, 2. So does beryllium, 1, 2. Okay, and these all have the same number of energy levels, 3. Now, when we look at our periods, period 1, 1 energy level. Period 2, 2 energy levels. Period 3, 3 energy levels. Okay, and that's what we meant by our periods show us the number of energy levels. Okay, so now what we want to do then is write this definition. So when we say the term valence electrons, all that's talking about is just these outermost electrons. So we're going to practice this more tomorrow. The Lewis dot structure is nice because if you remember back to oxygen, instead of having to show all the electrons, it only shows the valence electrons. So all you have to do is just draw the symbol and then valence electrons. And we're going to practice that a little bit more. Okay. Let me know if you have questions. Bye-bye.